I was born in Napoli in 1959, which was the year the first industrial robot was made. I did my studies and my whole academic career at University of Napoli Federico II, and I always wanted to reach my goals here.
Napoli is a city which naturally trains to complexity and inspires the people living in the city to develop a spirit of creativity.
Our Prisma Lab has been active in robotics since the mid-80s. We have grown up according to a bottom-up approach, from industrial robots to the level of interaction with the structural environment as in field and service robotics applications. Our dream and our goal at the same time has been to make robots useful and acceptable to humans. Our research work is in three main areas. We have developed bimanual robots and anthropomorphic hands for dexterous manipulation. Thanks to my ERC Advanced grant, we have expanded the team with complementary skills to work on non-prehensile dynamic manipulation and manipulation of deformable objects. We have designed sensorized grippers for handling tasks of robots in supermarkets and retail stores. Both industrial plants and civil infrastructures constitute hostile environments requiring mobile, marine and aerial robotic technologies. We have developed multicopter drones for non-destructive testing of bridges and viaducts and for aerial cooperative manipulation of payloads. We have designed a hybrid drone which can fly, roll along and inspect pipes, and an aquatic drone for eco-sustainable reuse of offshore platforms. What is the benefit of these technologies? Reduction of costs and risks. The operator can safely guide a remote robot, which then can execute tasks in a semi-autonomous way. In the field of surgical robotics, we have introduced techniques to provide the surgeon with enhanced multisensory perception, including tactile feedback, which is still missing in today's commercial systems. We have designed mini-hands and tools for laparoscopy, prostate biopsy and suturing. At the frontier of theranostics, we are developing a new version robot with a dual-arm micromanipulator for one-stop diagnosis and treatment of precancer cells during a colonoscopy. We have introduced the instrument of small-scale experiments aimed at turning prototypes into successful products. While strengthening the cooperation between academia and industry in the various experiments, there will be an added value brought by the project. Another instrument we have introduced is that of the challenges through the exploitation of synergies across all the stakeholders to speed up the process of bringing innovative technologies from research labs to industrial end users. We are also active as Digital Innovation Hub in the European robotics scene. Our research has also had a great impact on education. In the latest few years, at University of Napoli Federico II, we have been observing a constant increase of numbers of master's students graduating in robotics. Thousands of students at universities around the world study robotics from our textbook. The textbook contents are also available in terms of 2 MOOC courses for web learning education. Where is robotics going? Reaching for the human frontier, robotics is vigorously engaged into the challenges of new emerging domains. New communities of users and developers with growing connections to robotics are coming together, and thus our strategic goal should be one of outreach and cooperation with these communities. The inherent interdisciplinary nature of robotics is well captured by the Spring Handbook of Robotics. The handbook received the prestigious Prose Award in the category of Engineering and Technology, and remarkably, it was also the winner for excellence in physical sciences and mathematics, a true consecration of robotics as a science beyond the boundaries of engineering and technology.